Good morning everyone. I hope everyone are safe at home. Today I am going to explain you a very important electrolytic process, namely Chlor-Alkali process. The important chapter, the important content in acids and bases and salts in CBSE 10. Right? So what is this Chlor-Alkali process? Chlor-Alkali. Here in this process, sodium chloride, saturated sodium chloride aqueous solution is taken and electric current is passed into that aqueous solution. When electric current is passed into that aqueous solution, it undergoes decomposition reaction. It releases an alkali, namely sodium hydroxide and chlorine gas. Along with alkali and chlorine gas, hydrogen gas is also obtained. So we call this as Chlor-Alkali process. So once again I am telling you, it's an electrolytic decomposition reaction of brine solution. Brine is a saturated sodium chloride aqueous solution. You know what is sodium chloride? Sodium chloride is the common salt which we use as a kitchen salt or table salt, which is obtained from rock salt. Okay, now if this electrolytic process or electrolytic reaction is done in Kastner-Kellner cell and the process is electrolysis, the decomposition reaction is done with the help of electric current. So here the important reaction I am going to explain you. Please look at the board. Sodium chloride aqueous solution, so plus H2O, that will be writing. This is done in the presence of electric current. So here this brine solution, sodium chloride aqueous solution, decomposes into alkali as well as chlorine. What is the alkali that is obtained? The alkali that is obtained is sodium hydroxide, NaOH. We also call it as caustic soda. Caustic soda is the common name of the sodium hydroxide. And then you also will be obtained with hydrogen gas as well as chlorine gas. You know that in an electrolytic cell or during electrolysis there are two electrodes which are used. There is a cathode and anode, the two electrodes that are present. And sodium hydroxide, the alkali, and the hydrogen gas, these both are collected at cathode, and chlorine gas is obtained or collected at anode. Definitely there are many applications of these byproducts, sodium hydroxide and alkali, hydrogen gas and chlorine gas. So here already in this process we are obtained with three important compounds. Not only these three important compounds, with the help of these compounds that are obtained here, we can make certain important compounds like bleaching powder, baking powder and washing powder. What are these? Like you are obtained with three important compounds here in this Chlor-Alkali process. The first one is bleaching powder. So besides an alkali, besides hydrogen gas and chlorine gas, with this process we are obtained with three important compounds. First one is bleaching powder. The second one is baking soda. And the third one is washing soda. And of course, baking soda is again converted into baking powder even. There is a slight change or difference between baking soda and baking powder. I'll be explaining in the later. Baking powder. So let us start with the first compound, that is bleaching powder. What is this bleaching powder? Bleaching powder, the formula of bleaching powder is CaOCl2. Calcium oxychloride is the name of the bleaching powder. So here I am taking this chlorine gas, and this chlorine gas is pumped into dry quicklime or slaked lime. That is, slaked lime is calcium hydroxide. So CaOH twice, that is dry slaked lime. Here there is this very important thing which we have to remember. We have to take dry calcium hydroxide. So this dry slaked lime is treated with chlorine gas. then you'll be obtained with the bleaching powder, and the formula of bleaching powder is CaOCl2 plus H2O. This is the one of the important compound. This bleaching powder is used as a bleaching agent. It is used as a sterilizing agent. It is used as an oxidizing agent also. Bleaching agent, which is bleaching powder, is used as a bleaching agent in paper and pulp industry, and it is used as an oxidizing agent which releases nascent oxygens in many chemical industries, and it is also used as a sterilizing agent to clean swimming pools and all, like in sterilization of water, right? So this is how will be obtained with bleaching powder. Once again, I repeat, bleaching powder is obtained when this chlorine gas is pumped into dry calcium hydroxide. Next, we move on to the next one, that is baking soda. Next to bleaching powder, we move on to the next important compound, baking soda. Baking soda is also called as kitchen soda. This baking soda is used to make the pakodis crispy, and this baking soda is slightly neutralized with the help of tartaric acid into baking powder even. That baking powder is used in baking the cakes, and you know that how these cakes are spongy, and the sponginess is due to important ingredient baking powder. Now I'm going to tell you how this baking soda is manufactured. Brine solution is treated with carbon dioxide gas and ammonia gas. Then you are obtained with two important compounds, namely sodium hydrogen carbonate or sodium bicarbonate, and besides that another important compound, namely ammonium chloride, is also obtained. Ammonium chloride is used as a fertilizer. So here we'll be taking again brine solution NaCl plus H2O, and to this brine solution we are introducing carbon dioxide gas as well as ammonia gas. So here a reaction takes place and two important compounds are produced. One is sodium bicarbonate. The formula is NaHCO3. We also call it as sodium hydrogen carbonate. And besides that, you'll be getting NH4Cl. So here, coming to the uses of sodium bicarbonate. Sodium bicarbonate is a basic salt and it is used as an antacid or soda acid fire extinguisher also. Ammonium chloride is used as a fertilizer. But this sodium bicarbonate directly cannot be used in cakes because the pH of sodium bicarbonate is a little bit high, and due to the bitterness it is not used. Now we are like that sodium bicarbonate is neutralized with an organic acid like tartaric acid, such that any acid like tartaric acid or any organic acid is used in neutralizing the sodium bicarbonate, such that you are obtained with NaHCO3, which is neutralized with organic acid, and this is converted into baking powder. So this baking powder is the important ingredient which is used in cake, in manufacturing cake, which makes the cake fluffy and spongy. Now the last one is washing soda, and the third compound which we are obtained with in chlor-alkali process is washing soda. This washing soda is also called as sodium carbonate. Sodium carbonate formula Na2CO3. And how is this washing soda obtained? When we decompose, or let me say this NaHCO3 is heated, it is thermolytically decomposed, and then you are obtained with NaHCO3. When this sodium bicarbonate or sodium hydrogen carbonate is heated, then you are obtained with sodium carbonate Na2CO3 plus H2O plus CO2. So this is the important compound which we are talking about, that is washing soda. washing soda is sodium carbonate. But again here the obtained salt is recrystallized again, that is the salt is again dissolved in the water, and crystallization, you know about the process, how it is purified. Then after recrystallization, sodium carbonate Na2CO3 is holding 1 mole of sodium carbonate holds 10 water molecules. It is a hydrated salt. So sodium carbonate is a hydrated salt. First of all, we'll be heating sodium bicarbonate. By decomposition of sodium bicarbonate, sodium carbonate is obtained. Again, that sodium carbonate is recrystallized and you are obtained with sodium carbonate decahydrate. So that is Na2CO3 10H2O. This again, applications of washing soda, you know that it is widely used in domestic purposes. It is also used in making the glass borax. Okay, so I hope you all understood about the chlor-alkali process. In this chlor-alkali process, different compounds are obtained to start with sodium hydroxide, hydrogen gas, chlorine gas. In the same way, you are obtained with important compounds, namely bleaching powder, baking soda, baking powder, as well as washing soda. I hope everyone understood, and I want every student to make a flowchart like this and practice all the reactions and also read the applications and the uses from the textbook. Right? I hope everyone enjoyed. Thank you very much.